This is the patented TPF system. TPF stands for Thin Pack Fixture. It was designed to enable thin, flimsy items to be shrunk without buckling or bowing the product. Made to fit into any existing shrink tunnel, they can effectively run on low and high-speed packaging lines. Here we have the Space Saver 180 gravity turnaround conveyor, also made for light items. The 110-volt variable speed merge conveyor, merging two lines effectively into one. And the powered version of the Space Saver 180 for items under 4 ounces. The patented TPF system comes standard as shown here and installed in minutes. The basic unit comes with leveling screws. In full up position, the TPF will sit 1/2 to 1 inch above the conveyor surface. Moved into position, the leveling screws are planted into the corner made by the side chamber wall and the bottom. There is a 1 1/4 inch vertical rise to the rollers as they move forward and upward at a 45-degree angle. Most customers use the optional universal mounting clamp and adjustable T-bar crank as shown here. Each clamp has rubber pads to prevent scratching the tunnel. Mounting holes and screws are provided for permanent installation. Mounting on both ends of the tunnel, the entire system is easily installed by tightening a 1/2 inch threaded stud and clamping the unit to the outside of the width of the tunnel. Turning an adjustable hand crank on both ends of the tunnel lowers the TPF till the floating rollers just touch the conveyor surface or the top of the thinnest item to be run. The TPF also works well on solid or mesh type conveyor belts. Each roller is covered with black silicone rubber tubing to prevent the hot film from sticking to the metal surface of the rollers. Notice how each roller moves forward and upward as a thin book is introduced to the infeed of the shrink tunnel. Here we show our TPF literature made up of a piece of 22-point chipboard with a piece of paper folded around it and sealed in any polyolefin shrink film. Cryovac, DuPont, Okura, IPN, any will work. Low-density polyethylene will not work. With the TPF in full up position and out of the way, we demonstrate how badly the shrink force of the film buckles and bows the card. This is the plague of most printers or anyone trying to shrink thin, flimsy items. Each shrink film has its limit as to how thin an item it can shrink. Each thin item has a certain amount of grain strength in both directions. This grain strength is generally enough to withstand the shrink force of the film. The real problem with shrinking thin items is actually the problem of air trapped and heated inside the pouch sealed around the product. The air trapped inside the pouch expands to form a bubble. Now the shrink force is being exerted from the edge of the product to the top of the bubble instead of straight across the grain strength, causing the shrink force to pull the edges upward or downward, bowing the card. Now we will demonstrate the effectiveness of the TPF system by first lowering it into position so that the rollers just touch the top of the conveying surface. We will use the same carded TPF literature as before. We will also shrink a piece of literature made up of 3 folded paper pages. For these samples, we will use Renalon 3011 PVC film. An allied chemical or other equivalent would do just as well. First, the 4 TPF literature cards wrapped in a polyolefin shrink film. Often I use my business cards in the same film for demonstration purposes. We would like to point out that the TPF eliminates the problem of uncontrollable floating product in a high-velocity turbulence of shrink tunnels. This is often important when shrinking items like long-play record albums. This line is running fairly slow, 10 to 12 units per minute. We do have reports of customers running 100 to 120 packages per minute on high-speed packaging equipment. Next, 4 of the trifold paper pieces of literature in Renalon 3011. Incidentally, the TPF will work even in inexpensive 110-volt shrink tunnels. The residual heat buildup in the roller covers actually stabilizes the heat of the chamber, enabling it to effectively run polyolefin shrink films as well as PVC. See how the 22-point TPF cards emerge perfectly flat. The surface shrink of the film is actually retarded slightly by the TPF. This helps minimize propagation of the air vent holes in each package. Even the trifold literature pieces come out flat. It's hard to tell they even have shrink film on them. We recommend lowering the tunnel temperature 30 to 35 degrees when using the TPF. Cryovac D940 and IPM PSSF at 220 degrees. Other polyolefins 260 to 275 degrees. Most PVCs at 235 to 240 degrees. Some may think that these items are laminated. We have removed the shrink film to prove our point. Another area the TPF comes in very handy is with items with lots of spring to them, like knockdown corrugated storage containers. Here we have a piece of 200-pound test corrugated, folded 3 times. Notice how much spring there is to the folded piece. With the TPF in up position, we will show how the package shrinks without compression. Not very tight, is it? The spring of the folded piece has resisted the shrink force of the film. Now we lower the TPF down into position and try again. Installing a TPF on the discharge of the L sealer will also help achieve a tighter package, and in such cases often reduce the width of film required by as much as 1 to 1.5 inches of film per roll width, at much savings. When installed on the L sealer discharge, we call this a trapper. Now we see how the compression advantage of the TPF has helped. Some customers boast of saving up to 50% in shipper size or being able to palletize twice as many units on one pallet, bringing warehouse and shipping costs down substantially.